Okay, so now we're going to look at a couple more examples of solving equations by making use of this square root. So here we have equation 5x squared minus 40 equals 0. So we begin to try to get the square root by itself. Now I did an example in a previous video where I distributed the square root over the product with the x squared. Generally though, you would go ahead and just divide by that number, get it by itself first. So we have x squared equal to 8. And then we go ahead now and can proceed to take the square root of both sides. Square root of x squared will be absolute value. Square root of 8 will have to simplify. 8 can be written as 4 times 2, so we can rewrite that as square root of 4 and square root of 2. Now we get rid of the absolute value. When we do, we'll put a plus or minus in, and then we just simplify the square root of 4 times the square root of 2. So square root of 4 will be 2. And then the square root of 2 there you can't do anything with, so we get the answer plus or minus 2 square roots of 2. Now in our next example we have a quantity squared equal to a number. We still approach it the same way. Take the square root of that thing. Again, the square root of something squared will become absolute value. Square root of 36 is pretty easy to do. That would just be 6. So we get absolute value of x plus 5 equals 6. And again, at this point we drop the absolute value, move the plus or minus onto the other side. So here, at this point, we want to solve for x. So we need to subtract 5 to get x by itself. Now we do that to both sides. So I would write that as negative 5 plus or minus 6. But now, what that really means is one way it's negative 5 plus 6, and the other way it's negative 5 minus 6. So negative 5 plus 6 would be 1, and then negative 5 minus 6 will be negative 11. Okay, and so this time we actually get two answers. Well, we get two different answers. Before they were always just plus or minus the same number. Okay, let's consider another example. This time we have some ugly fractions in there, but we still proceed the same way. We have something squared equal to a number, so we take the square root of both sides. So we get x plus 4/3 squared. Square root of that equals square root of 28. Again, square root of something squared will just be absolute value. And then square root of 28 over 9 we can rewrite as square root of 28 over the square root of 9 because square roots distribute over multiplication and division. So we can drop that absolute value. Now when we do that, remember we need to make that plus or minus. And then to simplify here, we have square root of 28, which I can break down as square root of 4 over square root of 7. And then I have 9, square root of 9, which is 3. Now simplifying here, the square root of 4 could be replaced with a 2 because that's what it is. Square root of 7 would just have to be left alone. And then the last thing we want to do is bring that 4/3 over. So I subtract it from both sides, and I get my answer negative 4/3 plus or minus 2 square roots of 7 over 3. And that's typically how we would then just leave our answer like that. Okay? Alright, so hopefully this helps you. Now the main purpose of these last two examples is a little bit later on where we are going to talk about how to take a polynomial, just a regular polynomial that even has an x term, and write it in this format so that we can then use this process of taking the square root of both sides to solve the equation. So that'll be coming up in the future very soon.